Hey there, guys. Today we're going to do 10.5, which is on tangents. And today we're going to use properties of tangents, and we're going to solve problems involving circumscribed polygons. Remember, circumscribed means it's going to be on the outside of our circle. All right, so let's get some definitions out of the way. A tangent. You guys have heard of people say, oh, we went off on a tangent when you're talking about conversations. It means it kind of touched just a little bit on your conversation, but made you draw your conversation into another direction. Similar to a tangent in math, a tangent is a line that intersects a circle in exactly one point. So a line, well, not a lie, a line that intersects a circle at exactly one point. And so we see a picture that over here, that red line is going to be our tangent, and it's touching the circle in one spot, and that one spot is A, and that's called the point of tangency. So that's just the point of intersection. All right. And we also can see sometimes in circles we have what's called a common tangent. And so that means it's going to touch both of the circles, again, in only one point. So if we look here, our two circles are apart, and it's touching the circle here and this circle here. Sometimes the circles are touching, so it ends up touching into the same spot. We also can have two circles that have no common tangents. We can have two circles that have multiple common tangents. Please forgive my not very straight line. So if we look here, use a straight edge to draw the common tangents. If no common tangents exist, write NA. All right, so if no common tangents, NA. All right, so let's get out a line here. And looking at this first one, I can see right here that I have a common tangent. It touches each of the circles in one point. And then I also have one up here. And so it intersects them in one point. Looking at B, I'll tell you that I see 4 common tangents. So you guys try that. 4 common tangents for B. So find those. And then looking at C, C ends up only having 1 common tangent. All right, so you try B and come with that for tomorrow. All right, let's talk about this theorem. In a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So we would say that line L is tangent to circle S. Remember, circle with a dot, circle S. If and only if, some math shorthand, L is perpendicular to that segment ST. So we know it's tangent if it's perpendicular to the radius. All right, so we're going to use that. And so here we want to say is KL tangent to circle J. So we want to know, does this make a right angle? If it does, then we do know that KL is tangent to our circle J. So we see a triangle here. We want to know if it's a right triangle. What are you guys going to use? Think about it, think about it, think about it. Yes, we're going to use Pythagorean theorem. Now let's look at our difference between 2 and 3. Those both ask the same question, just different problems. And if you'll notice, in problem 3, it says that 12 goes this whole length. In problem 2, it doesn't say that, and so we can only assume that 9 goes to the edge of the circle. So we need to know, what is this length there? Well, if we're thinking about it, that length there actually is a radius, and so it's still 8. So the whole distance here, if we take our 9 plus 8, we get 17. So now we just want to see, is it a right triangle? So we take our legs squared plus our other legs squared, and we want to know, is it equal to 17 squared? All right, go ahead. 8 squared, we get 64. 15 squared gives us 225. 17 squared is 289. So are those two equal if we add up those 2 points? Yeah, we get 289 equals 289. So we say that yes, this is a tangent to our circle. Go ahead and I want you to try 3 on your own, but this time you're going to just use 12 as our hypotenuse. So pause the video there, do that problem. All right, now we're going to go a different way on the back side of the notes. Here it says find the value of x. Assume that the segments that appear to be tangent are tangent. So what that's saying is that they look tangent, and so therefore this is a right angle here. Again, problem 4a and 4b are very similar to each other, but slightly different when we get that hypotenuse. If we get to that hypotenuse, we're talking about this whole length here. And so that ends up being x plus 8. Whereas in b, the whole length ends up being 17. So we know that they're tangent, so we're going to set that up with a Pythagorean theorem. So leg squared plus leg squared equals the hypotenuse squared. All right, so x squared stays the same, plus 144. Now I see here I have a binomial squared. Thinking back, squared means times itself. So on the side over here, I'm going to think that that's x plus 8 times x plus 8. So here I need to FOIL. So x times x gives me x squared. X times 8 gives me 8x. Now I'm distributing my inside, so I get another 8x. And 8 times 8, we get a 64. If I look here, I do have a couple like terms, so I might as well go ahead and think about combining those. And so let's go ahead and look here. I see I have an x squared on both sides, so that's actually going to cancel out when I have 1 on each side. So we have our 144. Now remember we talked about combining our x terms plus our 64. And here we want to just solve for x. So minus over our 64, and we get 80 equals 16x. And we are solving for x in this problem. 80 divided by 16, we get x equals 5. So when we solve for x, we know that this is tangent because it told us. All right, so setting up your next problem, we're going to have a leg squared plus a leg squared equals the hypotenuse squared. Biggest thing here is just remembering that your hypotenuse is directly across from that right angle. Go ahead, pause the video here and finish up B for us. All right, so here's our next theorem. Theorem 10.11 says if two segments from the same exterior point are tangent to a circle, then they are congruent. If we look at our picture, both of our segments come back to point B, and they only touch our circle in one point, so that we can say that those two segments are congruent. So let's write this out in words. If AB and CD, not CD, CB, are both tangent to circle D, then our segment AB is congruent to segment CD. So if we look here, 5 says AB and CB are tangent to circle D. Find the value of x. Well, we know these two sides are congruent, so we're going to find the value of x by setting them equal to each other. Ooh, this again is some of that really hard math we've done. We're going to go ahead and minus our x to both sides. And let's go ahead and add a 5 to each side too. So we end up with x equals 20. Now I think you guys can do 6 all on your own. All right, on to our last topic. So we remember we talked about circumscribed is when it's on the outside, and the other thing that we need to remember is that the circle actually is touching this polygon every place. Whereas if we look at the polygons not circumscribed, it's not touching it everywhere, or the polygon's partially inside. So keep that in mind. All right, so last problem. Quadrilateral RSTU is circumscribed about circle J. If the perimeter is 18 units, find x. Well, we know perimeter is the measure all the way around an object. And so that means we can add up all the sides, and they're going to equal 18. The thing is, we don't have the measures for all the sides. So let's go ahead and talk about it. Here we have a point, and we have a line that's tangent and the line that's tangent. We just finished talking about that if we have two lines that are tangent to a circle and they both meet at the same exterior point, they are congruent. And so then that means that these two are congruent, and these two are congruent, and these two are congruent. Now, I know the measures for all my sides. So if I count, I have 4 x's, and I have 12. If we go ahead and solve that, we are going to minus the 12, so 4x equals 6. Go ahead and divide 6 by 4. I'll wait. Did you guys get 1.5? I got 1.5. All right. You do have a few like those on your homework tonight. Just keep in mind that if it's the same distance, if they're both tangent, it's the same distance away. All right, guys, go ahead and do that 10.1 worksheet, and we'll see you guys tomorrow.